Hi students, let us come back to your physics class. So today, in this sessions, we will discuss the collision between two particles in the center of mass frame of reference in an elastic collisions. So here, in the center of mass frame of reference, so what you want to do is you want to derive the final velocities in case of what is elastic collisions in center of mass of frame of references. Okay. So as I said in my last class, we know that what is your frames of reference and center of mass of frame of reference. If the inertial frame of reference is fixed with a center of mass of an isolated system, then what a center of mass is at rest with respect to the this frame. Then VCM equals to 0, so that P of CM, that means the linear momentum of that system is 0. So this frame of reference is called as what is a center of mass of frame of reference. So what it is? If the inertial frame of reference is fixed with the center of mass of an isolated system, then center of mass is at rest with respect to this inertial frame of reference, so that VCM equals to 0, then automatically PCM equals to 1 plus 0. So such frame of reference are called as center of mass or frame of reference. Okay. So now let us derive. So what are the velocities, final velocities of those two particles in such a frame of reference? Okay. So we know that elastic collision is a collision. A collision process is said to be elastic if the kinetic energy is conserved. Then what is your velocity of center of mass? So these things already explained in my what is first class. So definition of center of mass. Whenever a system consisting of what n number of particles, in such case it is what difficult to specify the velocity of individual particles. So in this case, so we are considering at what point in the system, that point we are calling it the center of mass. The point at which the entire mass of an isolated system is concentrated is called as what it is, center of mass of an that isolated system. So then VCM is equal to what? Summation of K equals to 1 to N IMK into VK divided by capital M. So this already I have given in my first section itself. So here, so our main concept is what is the final velocity in case of your center of mass reference frames. Okay. So this picture, the first part, the first one indicates what? Equal collisions. The second one is what is halfway collisions. So here, consider and what? A particle of mass m1 moving with a velocity u1 in the laboratory frame, and it collides with a particle of mass m2 at rest equals to 0. So here, m1 is the mass of the your particle, which is moving with the velocity u1, and it collides with an what? As a particle of mass m2 at rest, where it is in the laboratory frame of reference. The velocity of center of mass of this system of two particles related to the laboratory frame. So now let us write the velocity of what is center of mass of this system related to the what? Laboratory frame, related to the some fixed reference point is given by, that is the VCM. is equals to what? M1 U1 plus M2 U2 divided by M1 plus M2. So here in our laboratory frame, the second particle is at what? Rest. So that the velocity of center of mass of that system equals to M1 U1 divided by what is M1 plus M2. Okay. Next, if M2 is rest, that's already I have mentioned here. So VCM is equals to M1 U1 divided by M1 plus of what is M2. Okay. This shows that what? This shows that VCM, the velocity of center of mass, and the U1 have the same directions. What it indicates? The velocity of what? Center of mass, and the U1 means the velocity of first particles have the same directions. Okay. Next, let us write. Let us denote U1 dash and U2 dash. What it is? U1 dash and U2 dash be the initial velocity of those two particles, M1 and what? M2, before collisions in the center of mass of frame. Then, according to your Galilean transformation equations, so it is what? Given by U1 dash equals to it is what is U1 minus of what is this M. So that is equals to M1, M2, U1 divided by M1 plus M2. So it is equation number 1. Then U2 dash equals to U2 minus of what is VCM. Again, U2 is equal to minus of M1 U1 divided by what? M1 plus M2. And here you are getting what? Minus of M1 U1 divided by what is M1 plus M2. Okay. Because that your second particle is at what is that's fine. So you are getting minus of M1 U1 divided by M1 plus M2. Okay. So next, so here it indicates U1 dash minus U2 dash equals to and what? U1 minus of U2. So that is the relative velocities between two particles. So from this, what you have to conclude is, so U1 dash minus of what? U2 dash equals to U1 minus U2. That indicates the relative velocity between two particles in the laboratory frame and center of mass frame is same. The relative velocity between the what? Two particles in the laboratory frame and center of mass frame is same. Okay. So there's the meaning of that equation U1 dash minus U2 dash equals to what? U1 minus U2. The relative velocity between the two particles in the laboratory frame is what? Same. Is equals to and center of mass in the laboratory frame and what center of mass frame is what is same. Both are same. Now let us denote V1 dash, V1 dash and V2 dash be the final velocities of the particles M1 and M2 after collision in the center of mass of frame of reference. Then this V1 dash equals to V1 minus of V1, VCM, let's say the third equation. And similarly, the velocity of the second particle in the center of mass frame of reference it is V2 dash equals to V2 minus of what is VCM. Now, the total linear momentum is what it is. The total linear momentum before collisions and what is after collisions is not conserved, but it is equal to what is 0. That's fine. What is the total linear momentum before and what after collision is not conserved, but it is equal to what? 0. That's fine. M1 U1 dash plus M2 U2 dash equals to 0, and M1 U1 dash plus M2 V2 dash equals to 0. So this is what? The linear momentum of those two particles in the center of mass frame of reference. That's equals to 0. And this is what? The linear momentum of what? Those two particles in the what is center of mass frame of reference after collision. Okay. So from the above relations, let us make any conclusions, you have to draw the equations. So u1 dash equals to minus of m2 divided by m1 into u2. Say the equation 1. That can be what? Obtained by the above relations. From by using these equations, you can write it's what? u1 dash equals to minus of m2 by m1 into it is what? u2. Say it is equation number 5. So similarly, v1 dash is equal to minus of what? m2 by m1 into is what v2 dash. That is equation number 6. So here, the negative sign indicates that u1 dash and u2 dash act along the what? Same straight line. That in the above picture itself, this signifies, this shows that u1 dash and what? u2 dash acts along the same straight line, opposite directions, but opposite directions. Similarly, V1 dash as well as what? V2 dash. V1 dash as well as what? V2 dash are also acts along the same straight line in what is opposite directions as shown in the above picture. In the first picture itself specified. In the second picture are shown this diagram. Okay. So in other words, in the center of mass system, two particles move towards each other. Whatever those two particles are there in the center of mass, they approach each other, means they move towards each other before collisions and away from each other after collision. Before collision, what it is? They move towards each other, and after collisions, what they reside. Recede means they what away from each other's after collisions. Okay? If the collision is elastic, then I want to write the equations. The total, we know that the kinetic energy is also conserved. So that you have what? In the center of mass, frame of reference m1, 1 by 2 m1 u1 square plus of what? 1 by 2 m2 u2 square equals to 1 by 2 m1 v1 dash square plus of 1 by 2 m2 v2 dash square. Okay. So using equation 5 and 6 in equation 7, so you will get what? Now you want to insert the value of u1 dash and v1 dash where it is in this your equation number 7. So you will get what? u2 dash equals to what? v2 dash and u1 dash equals to what? v1 dash. What it suggests. Hence, in the elastic collisions, hence in the what? Elastic collisions in a center of mass frame of reference, the magnitude of the velocities, the magnitude of the what? Velocities of the particles do not change. What it is? In the center of mass frame of reference, in an elastic collisions, the magnitude of the velocity of the particles, whatever that magnitude, the velocity of the particles are there, they do not change. But that is there is a what? Only change in directions. There is a what? Only change in direction. U2 dash equals to what? V2 dash and U1 dash equals to what? V1 dash. That indicates the magnitude of the velocity of those two particles do not change. That is, there is what? Only change in the direction. That is the indication or significance of what? These two particles. So like this, what you want to obtain or you want to what? Derive the final velocities of those two particles in the elastic collisions of what? Frames of center of mass, a frame of reference. Okay. Thank you.